Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 40+ UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify innovative applications, build skills and standards, and advance partnerships to solve global challenges. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hi, everybody. Thank you for joining us today for this presentation and discussion with Iadine Chades from Monash University. My name is Deleshu, and I'm a postdoc at Oxford and soon to begin as an assistant professor at Columbia University. Iadine today is the director of the Environmental Informatics Hub at the Faculty of Information Technology at Monash and also professor of AI in the Department of Data Science and AI. Her research lies at the forefront of linking domain sciences, such as ecology, epidemiology, and social sciences, with advanced quantitative tools from AI, developing innovative methods for smart decision-making under uncertainty and resource constraints. So her PhD focused on developing work in Markov Decision Processes, or MDPs, and in 2006, she shifted her focus to applying these principles to conservation sciences, integrating AI with ecological and economic models to solve complex applied problems, and to be talking about the very plentiful work that she has done developing these tools for decision-making for biodiversity, all the way from more theory and those promises to impact. So I'll turn it over to you.
Thanks, Lily, and thanks for having me today. Today I'd like to talk about my experience developing decision AI for biodiversity, and in the first part of that talk, I'll present some of the work we've been doing over the last 17 years or so. And then I just want to conclude by thinking about the future for AI in the context of biodiversity. So biodiversity is in trouble. Species are disappearing. We have about 25% of threatened species. And not only that, but also abundance is declining. So the relative abundance of species has declined by 70% in 50 years. So this is well established. We know that biodiversity collapse also threatens our way of life. So it's been documented by the World Economic Forum. Biodiversity and climate change consistently dominate the top 10 risks published in 2024. We know that biodiversity underpins the global economy, and it's estimated by that about US 44 trillion of economic value, which is more than half of the world's GDP, is moderately or highly dependent on nature and its services. The biodiversity crisis is actually also a risk to our global health, peace, trade, economic development, gender equality, and connection with nature. So generally speaking, when we think about AI, there's two types of problem that AI is usually really good at solving. The first one is what we call perception AI. So that's about interpreting and understanding data from an environment. We think about typically computer vision research, natural language processing, classification, or prediction. The other type of problem that AI can help solve is what we call the control or decision problems. So making decisions and taking actions based on interpreted data. So in AI, we refer to this type of AI as decision making, planning, reinforcement learning, and a little bit of prediction too. And I guess a well-known approach nowadays is the deep reinforcement learning approaches to solve decision problems. So where is the opportunity for decision AI to actually help with conservation? Well, in species conservation, we actually tend to be interested in saving species as fast as possible, i.e. before they go extinct. Often we have a limited budget, and we also want to maintain people's livelihood. So we are not excluding the context in which these species are evolving. So with that first, we've had this objective, there is no decision problem. So if we're not able to articulate what we're trying to achieve, we won't be able to really provide good decisions. And so all decisions will seem equal. We won't be able to say which one is best. And so for conservation, finding the best decision to save species is quite difficult because decision comes at a cost. We often think about monetary cost, but also in terms of time. Time is almost limited resources because species systems change over time. So we think about the dynamics of the habitat or the dynamics of the populations, also the dynamics, the change due to climate change. All of that is quite needs to be accounted for, and it turns out that also often we're not sure which decision is best to actually save our species. So there's some risk and uncertainty that we need to account for if we want to make a good job at helping decision making to save species. And it's just often not one decision, but a sequence of decisions. So it's just not one single solution. We need to think what do we need on a time scale at a given time, given accounting for the current state of the environment, for example, or current state of the population. So it's complicated, but we know that the more we wait and the more likely our species are to go extinct. There's so many things we don't know and so little time to act. And we know that acting fast helps avoid extinction. The things we don't know are often noise in the system. The efficiency of our actions, of a system will evolve or response. And often we're not really good at knowing what the state of a system is, the state of the environment, the state of a population. So we can't really observe the system very well. It's improving, but we're still not there. So what is our solution here? Should we collect more data? Well, we know that the more we wait and the more likely our species are to go extinct. So collecting more data takes time and resources. What can we do? So this is where the opportunity lies for AI decision models. We can help support this decision making under uncertainty in conservation. And this has been the work that I've been involved in over the last 15 years. So the tool that I use called Markov Decision Processes, they are mathematical models. And basically they make some assumptions. They make the assumptions that we know where we are, we know what the state of the population is, and we know what the future dynamics are, so we know where we are going. So we know quite a bit. And we still want to make the best decisions at a given with this information. And then increasing complexity, partially observable Markov decision processes, a lot to account for uncertainty about where we are. So when we use partially observable Markov decision processes, we don't know where we are, but we do know where we are going. So we know what the future would look like. In conservation, unfortunately, often we don't know where we are going. And this type of problem is called an adaptive management problem. And we will see that we can use this tool to solve adaptive management problems. So just to give you some insights about the research we've been doing, providing support for decision making in conservation, I'll start with an example where we try to investigate whether or not the northern abalone and sea otters in British Columbia could recover at their could achieve their recovery targets at the same time. So sea otters prey on northern abalone. They've been extirpated from their habitat for some time, and now they're coming back in and sharing the same range, same habitat. And so the question for recovery teams is, like, should we actually reconsider our targets? Are they achievable? Do we need to think outside the box? What can we do? And using Markov decision problem, a Markov decision process, we've been able to help provide some guidance here. So looking at solving the problem of, can we actually achieve recovery targets for 200 species? We were able to model the problem, tracking the abundance of sea otters and the density of northern abalone, accounting for actions that could be implemented, such as introducing sea otter in a new habitat, anti-poaching activities, controlling the sea otter population, and sharing resources between a mix of anti-poaching and controlling sea otters. We also had enough data to be able to predict the future. So we had information on the stochastic population dynamics, the functional response between the two species, the occurrence of oil spills, the illegal fishing activity, and some management effectiveness. But all of that was still quite uncertain. So we had probability distributions to model this information. And then what we would try to do is provide a reward, a positive reinforcement when both species reach their recovery targets. And so the question we ask is, if we assume we are in this ideal world, can we actually achieve these recovery targets? So using models and solving this problem. So we just use your favorite algorithms to solve this type of Markov decision processes. And we found out that we couldn't actually recover both species at the same time. And through simulation, so that's on that graph, we see some simulation of our optimal strategy, and we're tracking both populations, and we're tracking whether or not we're achieving our objective at the same time. So, and on the x-axis, we have a time horizon. On the y-axis of panel A, we're tracking the abalone density and the sea otter abundance. And so we're tracking how they're doing. And then the panel B is telling us whether or not we can recover these two species at the same time. So when the reward is very high, we're doing a pretty good job. And when it's low, we're not able to do that. What we found is that even if we were to apply or implement the optimal strategy, we are not able to recover both species at their targets individually. So what it means is, like, both recovery teams should account for the interactions between these two species, and they may have to think outside the box to recover these two species now. So this is an example of how we've applied Markov decision problem, and we've developed this problem with managers on the ground, and we received some funding from WWF to do that, and it has informed it has guided some on-the-ground impact. So when we think about the multimodal model and the decision model Markov decision processes, they are relatively easy to solve. You can solve them using stochastic dynamic programming algorithms. They work well on small-sized problems. You can use deep reinforcement learning. We're solving very large continuous Markov decision processes, more complex. You can also use mathematical programming and allow for a richer formulation when you account for a lot of constraints in the system that your manager may want to see for accounting for the real complex world. The issue with Markov decision processes when we model a problem is modeling this type of problem requires experience. There are many ways of modeling the same problem. And if we want to achieve uptake in conservation, we need solutions to be interpretable so that you can be trusted, we can explain them, and we can ask very interesting questions and make sure it's doing what it's supposed to do. So we tackle this problem thinking, well, perhaps if we were able to represent the same problem with less states, less complexity, then we'll be able to increase the interpretability of our solutions and models, and therefore the uptake in conservation. So this is what we've done. We've done some work developing new algorithms where the managers actually give us the complexity they would like to see, and we calculate a solution that corresponds to that complexity. And in terms of complexity, they're giving us that number k, which represents the number of states. So if we go back to our problem, for example, the Ceuta and Northern Abalone, state space, so what we're tracking to make a decision, we actually have 819 states. It's quite a small problem when we think about problems we can solve in AI. But the issue is when we look at the optimal policy, it's a big mess. We can't really see what's happening in that decision tree. It's hard to read how we're supposed to do a good job. Of course, we can do a better job with visualization and so on, but the question isn't there, is can we actually solve the same problem with less states? And so this is what our algorithms are doing. We call that POMDPs. So we take the original problem, which we know is actually a correct formulation, and we ask the managers, how many nodes or in your decision tree would you like to see? And he give us a number, and from that number, we calculate, we're able to compactly represent the problem with 5 states, in that case, k equals 5. And so what does it mean for the optimal policy? Then we're able to represent the optimal strategy just using 5 states. So the managers can just ask to find out in which states they are, which is one of the SK node here, and then apply the optimal action, which is given by the arrow. And because it's stochastic, sometimes we're not going, we can go to different nodes. So we have to look at the next steps to know in which node we are. But basically, this is a decision tree, and it makes a massive difference in terms of interpretability and able to explain what we're doing and also check that it makes sense. So this is the type of new research we've been able to develop just listening to the feedback we got from managers on the ground and developing these new approaches. Another very interesting model that has been developed for some time, but unfortunately isn't really used anymore, and so I'm really keen for someone to keep working on that, is the factored MDPs. They're really able to, basically they take into account the independence between state variables explicitly. So they use dynamic vision network in the background. So there's a lot of work at the moment around causality, and if we could get causality back into the models of MDP or the solutions of MDP, that would be great. So factored MDP are particularly useful because they represent compactly Markov decision processes, and the algorithms, some algorithms, identify all the solutions, all the optimal solutions, just not one optimal solutions. And we know that sometimes we tend to be very, we actually don't know how many optimal solutions we may have. So this is very convenient for managers to know what are the alternatives. So some lessons learned developing and solving these MDPs and applying them on the ground, or getting some feedback from managers. MDPs definitely provide a rigorous and transparent framework for supporting optimal strategies, optimal management strategy in biodiversity and conservation. So the mathematics are strong, the theory is strong. What we found is interpretable policies enable the creation of transferable universal rules. So even though we solve the problems on small state space and action space, small size problem, the key here is to find general insights or universal rules that are applicable to different ecological systems. And this is important because we don't have data often in ecology, and threatened ecosystems or threatened species are poor data systems. I'd like to emphasize that explainability enhances transparency, trust, and the practical adoption of conservation strategies. So just like in many other domains where AI are currently developed and applied, this is conservation is a human domain, so humans actually apply this decision on the ground. So if we can't really explain what they're doing and they're not transparent, we're not being very useful. A small point on, I've talked about optimal strategies, but actually in conservation, optimal can be the enemy of a good. So we're making a lot of assumptions when we're modeling, and so we have to be aware of that. So another problem that is very interesting with AI decision models is when threatened species, we have to manage threatened species. So threatened species, by definitions, are low in numbers, and it's really hard to detect them. So some species have been presumed extinct before being inadvertently rediscovered. And some of the questions that managers have are, in absence of detections, what does that mean? How long should I invest in management? When should I shift my resources from managing to surveillance or stronger monitoring? And then when should I stop managing an area and switch to another area, another location? So we could be managing a species that is extinct or not managing a persisting species. So it's a hard decision problem for managers, and we can be helpful. And basically what POMDPs are doing is they account for the fact that we have imperfect detection in the system. So if we knew exactly where we were, we would have perfect observation of a population either extant or extinct. But what we're getting instead is just an observation. So it's unclear whether when we have an absence of observation, whether or not the population is extant or it's extinct. So partially observable Markov decision processes augment Markov decision processes. So by accounting for these two elements, the fact that we have observations and probability of detections. So partially observable Markov decision processes, they're good at providing decision supports when we don't know where we are exactly, but we know where we are going. So we have information about the future. Yeah, some examples. So we've applied these approaches and help managers guide their decision when it comes to when should they stop managing or surveying cryptic threatened species. And this is what the decision tree looks like, or decision graph. And basically the optimal time to switch decisions depends on management and monitoring efficiency. So these numbers would change depending on the context in which these threatened species is managed. So POMDPs are by far the most useful decision model from my perspective in conservation. But it's solving a POMDP is just the beginning of a story. What we're aiming to discover are mechanistic insight with general rules. And one of the issues is that POMDP solutions are difficult to represent and interpret even more than MDP. So we have similar issues, and we've developed, we've tried our best to make these POMDPs more accessible to managers. And we work with the Saving Our Species program, for example, and develop, Shania applications to help them use these tools. To help them use these tools. But I want to and we've developed algorithms to simplify these decision trees again in the context of POMDPs. And then I need, okay, and transition. Yeah, and so we have these algorithms now that allow us to simplify the solutions. And it's very useful for POMDPs because they can also help us solve a problem that we call adaptive management in conservation. And adaptive management problems are cases where we don't know what the future is for this species. So we can't really predict what the future will be. We just have some assumptions or some scenarios of what it might be, but it's very uncertain. So deciding when we don't know the future in conservation is called an adaptive management problem. And so adaptive management is basically the principal tool for conserving endangered species under global change, but it's also in the conclusion of most papers that try to manage ecosystems or species. They say we should always try to manage species using an adaptive management program, and this is because the future is uncertain. From an AI perspective, it's a difficult problem to solve, but what we found is we can model this type of problem using POMDPs. So POMDPs actually provide optimal adaptive management strategies, and we can help optimize the adaptation over time by learning while doing. So it's a little bit like playing a chess game, and we're learning as we go and adapting our strategy in the best way possible. We can also account for imperfect detection and changes in the future future dynamics. So it's perfect for climate change issues, for example. And we've developed algorithms to solve this type of problems. We've applied it to very complex decision problem, for example, to manage shorebirds in changing climates. And we found some good results using simulations. We also, again, work with Saving Our Species program to test whether or not our assumptions or our approaches were adequate. And we also provided ways of increasing interpretation of adaptive management solutions. This is the type of work that is really needed when it comes to uptake of our approaches. So AI for decision making is actually progressing rapidly. We hear a lot about AI for monitoring for biodiversity. But AI for decision making is needed. And we need new research because traditionally decision AI has been developed for autonomous systems. So think about self-driving cars, robots. Conservation is a human-operated system. So we need interpretation, interpretable solution, explainable and trusted solutions. I also want to emphasize that when it comes to conservation, we don't necessarily have a lot of data. This is a poor data problem. And it is very important to realize that not all data has the same value. And we must and we should optimize data collection, especially in the context of urgent decision making. And we can also do that using our approaches. This work has been co-designed with managers. We need integrated research to responsibly develop AI decision for conservation. It's also true in other disciplines. But the reason is we actually know very little of the impact of bias in conservation and ecological systems. And I'm really worried about unintended harmful consequences as a possibility. So recently, I took up a new position at Monash, and I'm leading the Environmental Informatics Hub, as Lily said. And in that new role, I'm aiming to develop the AI that biodiversity needs. So we are in the Faculty of IT. So, and we are looking at developing interdisciplinary collaboration in practice. So all of our projects are co-designed with NGOs, government, and industries. And so while I set up this hub, I'm realizing a few things, and I need, and I would like to share these thoughts with you. I realize for initiative like the Environmental Informatics Hub to be more useful and impactful, we actually need a paradigm shift. What we need is a global coordinated approach to developing AI for biodiversity. So what I'm seeing is we're doing very well at developing AI application for targeted problems. My perspective is that AI is beyond the proof of concept stage. We know we can develop powerful tools and models. My issue is I'm not sure if this is the best use of our AI capabilities and initiatives to reverse the biodiversity crisis. So I've been thinking about developing what we would, similarly to the global biodiversity framework, what we would call a AI for the global biodiversity framework initiative, and I'm looking for help to develop this coordinated approach so that our AI that we would develop and the efforts we're putting right now, initiatives such as the Environmental Informatics Hub here, but also there are a few other initiatives in the US and in Europe, actually counts towards our global biodiversity priorities. And what I'm seeing is we need it now so that we can show impact of our research and make sure we're actually delivering on our priorities. Thank you.
Fantastic. Thank you so much, Iadine, for taking the time to share the wide-ranging work that you've done first on developing these methods, but then also working very closely with practitioners and across NGOs and government to actually develop these tools for their context and then go back and figure out how to scale them. And thank you for also kind of laying out the distinction between AI for perception and AI for control and decision making, and why we need both and how they really solve different kinds of tasks. So I want to start by asking, as you were saying, like it takes a lot of time and expertise to develop these models effectively, and this work has to be done in conjunction with stakeholders. And how do you think about like the opportunities to make this work more generalizable? Because of course, there's a risk of we don't want to take one model that was developed in the one landscape and apply it to another landscape, but we also want to like not duplicate efforts. So where do you think of drawing that line?
That's a very good question, Lily, and I've been thinking about it a lot because in my role, since I'm actually have expertise in developing these decision models to solve conservation problems. I'm often asked to write these models again and again, and I feel like sometimes it's a little bit of deja vu. I love doing it.
Yeah.
I love feeling useful, and so we've just started actually a PhD scholarship on that topic, using using what we think the opportunity is actually using generative AI to help with that work. But we want to do it so it's secure and does the work that it's supposed to do. So the idea here is, as you said, not to duplicate efforts, and the opportunity, and the time is right. Like the opportunity is there. We know we have similar conservation planning problems coming up.
Yeah.
We have Markov Decision Process problem coming up similarly, and so we're looking at developing a tool that will do that job well and safely and responsibly. Yeah. And so that's you'll have to come back in 3-4 years and or help us develop that, by the way.
Yes, wonderful. And then I guess one thing I also want to point out there is the need to develop these kinds of bespoke models also applies in perception AI as well, because even though we have these like wide-ranging like camera trap data and bioacoustic data that and there's very fantastic models developed, such as SpeciesNet and at BirdNet, I think it's called, to take models that have been trained on other data that practitioners can use. But oftentimes these models still have to be fine-tuned. So if you work in a different landscape, like unfortunately these models do perform much better in North America and Europe. So if you're working in a context that has a lot of endemic species, people still have to, like think about retraining and developing their models for these contexts. And that is kind of what we're saying as well about these models for decision making.
Yeah, and on that note of the reliance on large data set to actually retrain, or like smaller data set to retrain these models. We're also looking at edge acoustic monitoring, and so the opportunity here is to actually develop these minimal models, the smallest model possible that can fit on a device, and would allow to instead of because in Australia we work in remote areas often, and in a lot of places in the world that are hotspot of biodiversity. So the communication between the device and in the database would, or the manager would only be, I've identified this species instead of the entire video or the entire sound that is then processed behind a desktop. So this is the opportunity we're seeing with, it's I think going back to optimal is the enemy of a good. So I think in that case we would like to find that trade-off of like minimal models that are agile and we can deploy in the landscape and cheap. So it's a win-win. I see that as a win-win opportunity for us to make a difference.
Fantastic. And on the topic of smaller models, it was great hearing about your work on KMDPs. Um, and you had that really nice diagram of where here is the optimal policy in this very, very large state space, and then here's what the policy looks like when you reduce it to just k equals 5, when you only have 5 state spaces that you're considering. And I was wondering if you had a sense of like what the trade-off is between like what would we lose in terms of like the quality of our decisions when we are making this reduction?
Yeah, that's a very good question. I actually didn't touch so much on it during the presentation, but yes, there is often a trade-off between, the compact solution, if we want to compact solutions. But what we find is that trade-off is actually quite late in the applications and that like problems we looked at. We can actually reduce the size and not lose a lot of performance for a very long time. So it's problem dependent, of course, but what we do to help the managers understand what it means to set a number just k equals 5, we're also providing, this is what it means on that profile. If you had 1 or 2 more states, this is how close you'll be to optimal. So we give this information of loss of performance, and it's for them to choose, whether or not they can deal with that complexity. What we know is usually if there's more than 10 nodes, it becomes quite difficult for managers to understand what's happening. So we know that 10 is about the magic number from practice. So this is what we're aiming for in general, but it's very tricky. But again, optimal enemy of a good, but it's better than probably in some cases not having access to these decision support tools.
Yeah, fantastic. I'm also curious what how you would think about this problem of if we have a model that has various recommendations for actions, and then we take that action. At what point do at what point do we move to the next action? Like when in computational terms, like when does a state transition? Like what is a time step? But how do you think about that in practice? Is it a day? Is it a year? Is it longer? What are some examples in the context that you've worked with?
Yeah, that's a very good question, and it varies a lot depending on the system you're studying. So it's basically it depends on the biology of a species often you're studying or the dynamic of ecosystems. So if you are, just to give you an example, so I think the answer is the practitioner, the managers, as they have to tell you what is a good time frame, and you have to and I think they give you some information. They don't really give you the time frame that fits the assumptions of the Markov decision processes, because Markov decision processes, rely on the Markov property to actually be formally correct. So we also, as modeler, we need to make sure the Markov property holds. But basically,
And will you explain what the Markov property is, just for
yeah, so it says that at any time we are able to predict the state transition given an action and a state, just accounting for the previous time step. So we don't need to look too far into the history of state action transition. We just need the previous time step to be able to predict the next time step. So it's very convenient because we basically all our calculations are a lot faster. and all of that. But to give you an example, if you think about growing restoration of a forest, we know that from the time we plant the tree to the time we can say it has a seedlings to the time we can say the tree has survived takes between 3, 5, 10 years. So the time step will be different, and then some species have a life cycle that is much shorter than others, and so it's really dependent. And I think you have to learn what are the assumptions that your models are making, and they need to be and then you have to understand what the problem is. It might be a bit tricky for generative AI to get to find this type of solutions, but a human can do it. So that's a good news, I guess.
Wonderful. Maybe the next thing is, what do you think about with regard to spatial heterogeneity? So across the landscape, like there's going to be different species populations at different parcels of the land. Would your recommendation be to build a different, MDP, or, like you'd apply the same MDP, you just have a different state value for each of those parcels of land, for example, and then you would apply different policies to it? Is there a way to kind of like coordinate across all of those units? How do you, how has the work that you've done kind of translate to, the larger landscapes and spatial heterogeneity?
Yeah, that's a good question. So the problems I've presented, there are just a couple that are spatial. So the migratory shorebirds problem is spatial, and what we did is we use a network, a graph in the background to account for the spatial heterogeneity of a problem. So typically, when you add time and space, it becomes quite difficult to solve. So you have to be careful, only account for the information that is important. And so the reason why you would account for space could be because your budget doesn't allow you to think just locally, so you have to think globally. Another reason would be there are spatial interactions between habitats, or the species are moving, and so in that case, what you're implementing in one location influence what will happen in the next door location, right, in the next location nearby. So these are the information you really need to be careful about when you try to solve these problems. And so what I'm finding is making sure what are the dependence and independence between the information we're trying to account for, and how do we influence the decision process. So it's a tricky, it's a fantastic opportunity to really make a difference in terms of AI and combinatorial optimization. Like, we're really good at solving these type of problems, and it's just starting to be explored from my perspective. Like, we can do a lot more in that context. Especially using models like the graph neural networks. They're just fantastic tools.
Fantastic. Thank you, Iadine. So now just thinking, from the perspective of a practitioner, listening to this talk and saying, okay, well, I would really be interested in piloting like these kinds of technologies, these types of decision support tools in my context. How would they get started? Other than sending you an email?
That's a good question. How do you manage how can they know that they need AI? I think I think the first thing is like, I specialize in decision AI, but I think it's true for for any type of AI. I think seeing the opportunity for cost effectiveness, or time efficiency, or effort. So feeling the need, if a manager feels the need that we can be better at this, like we can do a better job. Like, usually they have the intuition that they can do a better job, and they say, hey, can we, they just ask a question, this is my problem. I feel like we can do a better job. What do you think? And so we brainstorm together, and it's back and forth. And after a few hours, we come up to we come up with some options. It's not necessarily straightforward, but what really helps is I guess the AI hype. Because now everyone knows about AI. And for a very long time, I felt like I had to convince managers, hey, like you have a hard decision problem. How about, hey, do you want to work with us? Like we're trying, like, I think, it's really hard to be in that situation in a way. So if people don't if people don't see the need for it, we should definitely not work together. Like this is not a good,
Yeah,
good, it's not a good use of anyone's time. But what I'm seeing is people are a lot more aware of the AI opportunity, and it's a lot easier nowadays to start these projects um, and really get better at what we're doing, either monitoring or decision or prediction. Yeah.
fantastic. Thank you. Thank you so much, Iadine. So what maybe another question is for I'll ask them two related questions separately. So the first question I'll ask is, we've seen over the past 3 to 5 years, a huge increase in the number of like ecologists and conservation practitioners who are kind of upskilling in AI. So, they're really learning about machine learning, they're learning about data, they're learning about how to build predictive models oftentimes. And, certainly this has been a big investment that the community has made, and it's not unique to biodiversity. It's, we're seeing it in kind of every sector. Um, so what would you recommend to somebody like that who is coming more from the ecology and conservation practice side, who kind of has already developed this background in predictive machine learning? How would you recommend they kind of get into more decision making AI technology?
Yeah, yeah, that's a very good question. So um, so I think there's a huge amount of resource online to help you. There are also some primers that have been written here and there in different disciplines that people can read. And won't plug us, but because we wrote a POMDP primer in methods in ecology and evolution. Um, but
Maybe
I think
I think we can link that on the I think we can link that to the video.
okay. So I think the hardest part of the journey uh, um, is actually understanding the opportunity. It was like this is what it's for. So
Right.
having this yeah, having this intuition and correct intuition of what does a decision model AI need and what will it provide. Um, and then the technical aspect, I think nowadays you can easily craft, a first model. It might not be completely correct, it might not be perfect, but but I think it's very accessible for people. There's so many tutorial on deep reinforcement learning, for example. I don't recommend studying with deep
Yeah.
reinforcement learning. I would recommend starting small with like a smaller, problems like the ones up, like the Markov Decision Processes type of problem. But yeah, I think a lot of information is now available. What I would like to see more is interdisciplinary training
Yeah.
opportunities, and I think it's lacking at the moment. We have some. I just saw that there was a computer vision training opportunity for ecologists. I'd love to see that in every domains where AI could be useful. Um, yeah, so again, like what is our global strategy there? How can we make the biggest impact? Yeah, with our resources and our time. these are very important questions, and I want to contribute to it, and I want to make sure we have an agenda and we're strategic about the way we go about it. Yeah.
Absolutely. Thank you, Iadine. And for my second part of this question, for somebody who, is more of an AI researcher, who, is really interested in conservation, or like a student in AI who's interested in getting started, how would you recommend to them of, like finding the right types of like conservation problems, and just starting to work more in this discipline?
Yeah, that's a good question, and I had to go through that process with the Environmental Informatics Hub, because we've been recruiting a cohort of PhD students, and we'll be recruiting in the next 3 to 5 years continuously. So what I found is I think the new generation of students, they're really, really eager to contribute to the environment and to
Right.
biodiversity, and they 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 really want to make a difference in terms of their values
Mhm.
and improving improving our health and environment. So they're really concerned citizen, and it hasn't been from my perspective. I'm receiving a lot of emails of people that are really that are really dedicated and really want to make a difference. So, my tips for them is, unfortunately, you need to have really good grades everywhere. If you're, you know, so it's really you have to, yeah, you have to be
The advice was to
starting to
do well
be,
in school.
yeah, that's passion just gets you one way, and then like it's hard to, yeah. But we're thinking about alternative models to actually, how to encourage, out of like academia um, involvement. And so I think for students, just curiosity, being curious,
Yep.
um, um, going to seminars in different. There's lots of seminars online.
For
Looking at,
example, this one.
yeah, look, perfect. This is a perfect opportunity, right? And also students, I think they'll benefit from understanding the bigger picture.
Mhm.
What is the bigger picture? What is our world? What are the important biodiversity challenges? What are our targets for the, in the global biodiversity framework, for example? What does that mean? What do we, really understanding that it's just a planetary challenge, as well as a local challenge, because our species are going extinct, locally. So yeah, I think curiosity would be the main attribute that would get students a long way.
Yeah, fantastic. And then one specific question that came in from a future audience member is this question of how can somebody make contributions to AI biodiversity if their full-time job is not in this area, and where might there be dormant open source projects on the internet, and where would one start to search?
Yeah, that's a very good question. As I said, we're reflecting at the moment of like what can we offer for
Right.
this for this audience, and there are some ideas like there are some you know citizen science opportunities that we're thinking about reshaping in, like citizen science AI, for example. Um, and s- and so I think it's under development. I've you know um, we want to make sure people use their time
Yeah.
um, in the best way possible. I want people to feel like their time is valued and they're contributing. So that's why the idea of having a global coordinated approach to AI for biodiversity is actually so important, so that people can actually have, they know I've contributed to that, like I'm
Yeah.
making a difference. And so yeah, this wonderful. This is like we should do a better job, and I'm really keen to come up with some opportunities.
Wonderful. And I'm, just because you brought this up and we're sitting on this slide as well. What to you does a global coordinated approach to AI look like? So like who needs to coordinate? What do we need to coordinate over? Um, How?
That's
Yes.
that's a very good question, Lily. So I'm starting on that journey, and so the first thing is raising awareness. This
Yeah.
is what I'm seeing. I think we're doing a great job, you know, solving these small problems. Like, or when I say small, I mean just identify
Yeah.
localized problem.
Mhm.
Um, but we're not very good at um, going to the big issue, solving the big issues from right now in AI. Like there are some initiatives, but it's emerging. Like it's not like I'm not saying um, yeah, I'm not saying this coordination. So
Yeah.
what do we need? Who do we need to talk to? Well, if there's someone in the audience that can help us figure that out, that would be great. No, but more seriously, I'm actually working here in Australia with several universities and ecologists and members of the IUCN and the COP, and so I'm pushing for that agenda to be on the table. And a lot of it is about one is first, is there actually a real opportunity to develop AI for the you know uh, for biodiversity, for the GBF? I believe there is I believe there is an opportunity. I believe it's a true opportunity, but others might not think so. So I want to have this conversation and say, do you see the opportunity? Do you agree? Can we set something together? Let's invite all the actors right now in the world internationally, including all representatives of AI for Biodiversity, webinar, and let's see what we can do. I know there's some already some NSF initiatives going on, um, but getting that global agreement, I think. And about what are these priorities for AI would just get us allow us to be a lot more strategic and work together with the resources we have. Yeah. So I think so to answer your question, uh, like I want to test. I believe we need it, but I want to test it with the actors. With basically the actors that are behind the GBF targets
Mhm.
and my colleagues and NGOs and all of that.
Fantastic. Yeah, I'm curious if you have kind of like one use case where there's a like an environmental setting where you think, MDPs or POMDPs or any of the other work that you've talked about today could where these types of tools from Decision AI really could contribute to, this specific problem. And you're just waiting for like, the right practitioner to identify, to work with, to develop and implement this.
Yeah, well, if we think about the the GBF targets of a global biodiversity framework targets, one of the most famous one is 30 by 30.
Right.
30% of it has to be protected by 2030, and it's in 5 years. Um, this is a very difficult problem, right?
Yeah.
And so what we need is it's a difficult decision problem where, how, who needs to be involved, what are the
Yeah.
compromise, what do we need to account for, what are the constraints. So typically, and we want to, make sure we do a good job with representativeness and all of that. So yeah, this it's from my perspective is one of the most well-known targets of a
Right.
GBF in the decision world. Um, and having a global, providing the tools for um, that are coordinated would make a big difference. And of course, the decision has to be at the local scale. We're not going to tell any countries where they should go, but we can provide these tools so they can
Yeah.
put their data in, put what they care about, see
Yeah.
what the targets are. So
Yeah.
really something,
Really highlight like these are the opportunities for efficiency. These are the opportunities, to like do the
like,
most with a very limited budget. And get
exactly.
closer to these goals at a faster time.
Yeah, so it's not about removing the decision, like the decision-making aspect from the the population and the countries. It's about providing the tools to make sure they are aware of the trade-offs and they can make informed decisions. Yeah, so.
Wonderful. And a last question I'll ask, which is moving to a very different area. But you mentioned at one point that you're developing tools. You're looking at opportunities to use generative AI to develop these, to first specify these MDPs so that it's easier for decision makers. You can adapt it to more context. I think people would be really interested in hearing a little bit more about that and what you see as the opportunities for generative AI.
Yeah, so many opportunities for generative AI. So yeah, so the translation of natural language into a model um, is a decision model is you know is something that right now generative AI doesn't do very well. I've tried it, I can tell you. So the opportunity here is to provide something that works and is secure. But we can't, it requires research. Like it's not my area of expertise, and so we have academics here, but are really good at doing that. So we're working with them. The other opportunity for generative AI is, evidence-based conservation. Like a lot of the conservation has a lot of has been built on a lot of gray literature, often in different languages, and there's a lot of information there that needs to be synthesized and put into databases and that we can reuse and all that. The other aspect too is what we're looking at in using this generative AI tool and natural language processing is looking at causality, finding finding this causal relationship between threats, biodiversity, on the environment, or management. These things that are still unknown. There's still a lot of things we don't know.
Right.
So great opportunity, and so we have two projects starting on that. I think there are so many opportunities, but we have to be careful of
Yeah.
having the right researcher working alongside practitioners to really understand the problem, making sure they're solving the problem that is needed rather than the problem we can solve and we think it's needed. And secondly, helping managers to actually use the right tool or making sure it is safe, because I'm seeing a lot of I guess like it's as you know it can be deceiving deceiving sometimes to use this generative AI tool. Like it's often incorrect in some
Yeah.
cases, and
Bias and ethical implications of AI are things we haven't begun to touch in this session. But good thing there are other talks in these series who will focus
yeah.
so with that, I'll draw us to a close. And thank you so much, Iadine, for the wonderful work that you've done in the space for 15 plus years. Very exciting to see the creation of your environmental informatics hub, and excited to follow what will come out of that. And I'm, just really optimistic about what we can do, not as, a cure-all, but as a decision support tool and an aid to, help us make the best use of limited resources and deal with these vast complexities of ecosystems and ecosystem management in a more tractable way.
Thanks so much, Vivian. Thanks, everyone.
Appreciate it.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, Connect with interesting profiles or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.